You're on it.
Oh,
Okay, so how was bioenergetics? How are the three systems doing?
doing good.
Okay.
It was easy, sir. मतलब इतना वो tough नहीं था.
Okay.
So first one is phosphagen.
हाँ.
Phosphagen होगा या phosphagen होगा?
Phosphagen.
Phosphagen. So sir, it comprises of this. First of all, phosphagen. Second one is glycolytic, and third one is this oxidative. So first two are
Anaerobic.
First two anaerobic, and third one is aerobic. Yes. Because this system requires oxygen.
Exactly.
And first two doesn't require so much of oxygen, but and in the second one, carbohydrates plays a important role in functioning. Okay. And first one includes everything.
First one
in short includes like carbs, protein, fats.
So what's first one?
Phosphagen.
Phosphokinase or phosphocreatine or phosphogen system.
Phosphocreatine. Phosphocreatine.
So what I want you to do is we will move on to the skeletal muscle, but as a homework or as a project for next time, what I want you to do is I want you to make a table. So you have three systems. Then you have three system ka time that it is usually active. Then three system ka energy resources. Then three system ka ATP output.
तो ये सब मेरे को एक टेबल बनानी है, right?
हाँ.
So first one is phosphagen. Second one is non-oxidative. Third one is oxidative.
हाँ.
ठीक है. So first point is time.
Yes. Or duration time. You can say.
ठीक है. Second.
Second we can say ATP output, the number of ATPs that it outputs.
ठीक है.
Third, what I want you to find out is hold on. What was it?
Exercises?
No, not exercise.
No.
What it synthesizes to produce ATP?
Synthesizes.
So it has to synthesize something, means process something to produce ATP. Right? Right?
All right.
अब आपने ये long term effects of exercise पढ़ा?
नहीं पढ़ा सर फटाफट अभी पढ़ लेते हैं. Okay. So long term effects of exercise training on bioenergetic pathways. Endurance training has been shown to increase the capacity of the oxidative system to produce ATP. Sir, but endurance training is less time and more reps अगर exercises में देखें तो.
Endurance
suppose
training.
1 minute है, 1 minute में.
Go on.
Suppose 1 minute है, 1 minute में how many push-ups can you do? So that is an endurance train.
That's power. Power is when you have time versus reps versus weight. That's power. Endurance is how long can you go?
How long can you go? Yes. Right. This is directly attributed to the increased mitochondrial density noted in muscle that has undergone prolonged endurance training. Indeed, it appears that as much as a doubling of mitochondrial content. So, what is mitochondrial?
Mitochondria.
Mitochondria.
So mitochondrial content can occur in training muscle. So what is mitochondria? Mitochondria is basically the powerhouse of a cell. So I'll show you here. तो आपको exact idea आ जाएगा. Okay, so if you see and refresh your biology a little bit, you will be able to recall and recognize. So this is a cell, a typical cell, right? Now you have mitochondria like this in the cell.
Okay.
Right. So mitochondria is like the generator. That's where the ATPs are produced.
Sir, already cells are so small in size. उसके अंदर भी इतनी चीजें होती है.
Yes, yes, absolutely. So if you want to see a better image,
God.
right there, right? So these are the things, and it has a nucleus inside. Now again, what you might wanna how do I say this? आपका ये जो last statement है, this last statement, now if we change our thinking a little bit, right? And change our thinking, I mean from a scientist or from a educated person's view, there is nothing which is small, there is nothing which is big, right? Yes, of course, from our reference point it is, but then in the universe, right, you have to understand that everything in its own size is okay, right? Because let's say, for example, for the galaxy we are very small, for the universe galaxy is very small, right? For a cell we are very big, for an ant we are very big. So from where you're looking at, things may appear big and small, whereas the spectrum is pretty much unlimited, right? Because now what is happening is new and new knowledge is coming, and they are also realizing that there is also subatomic size, right? Now this cell itself may carry so many millions of atoms inside. So you can imagine the size of an atom. Now there is also subatomic content, so it may go on and go on and go on. Similarly, it may go up, right? Okay, so you understood what mitochondria is? Right?
Okay. Noted in muscle that has undergone prolonged endurance training. Indeed, it appears at as much as doubling of mitochondrial content can occur in trained muscle, leading to a similar increase in the enzymes and other protein involved in the oxidative synthesis of ATP.
So what they're trying to say. What is the second point trying to say?
So, sir, it has shown that this mitochondrial density, जैसे like we increase our endurance training, वैसे mitochondrial content double हो जाते हैं.
Perfect.
With the with the time duration, and leading to the similar increase. There is an increase in enzymes and other proteins involved in oxidative synthesis of ATP.
Okay.
So also मतलब mitochondrial to increase हो ही जाते हैं, but similarly there is an increase in enzymes and other protein as well.
Exactly. So from an exercise point of view, how does sometimes this can contradict between endurance training in benefits to weight loss or benefits to excess fat loss? How can they contradict? Right. So what do I mean by contradict is here, what they're trying to say is when you do endurance training, the mitochondrial capacity increases. Right. If the mitochondrial capacity increases, it's gonna generate more energy. If it's gonna generate more energy, obviously more synthesis from carbohydrates and proteins and fats is gonna take place. That is breaking it down. So more endurance you have, the more breaking down capacity you have. Right. So why do people say that if you do a very, very vigorous endurance training, you will not burn fat, you will not lose fat. In fact, you'll gain fat because your metabolism will become slow. Now, which of this statement is correct?
सर एक बार लास्ट लाइन वापस बोलना, आपने क्या बोला?
जैसे for example, if you might have noticed a lot of aerobic, I would say, coaches, right? Over the period of time, they tend to gain a lot of weight.
Okay.
People who do a lot of running, when they stop it, after that they tend to gain a lot of weight. So it is a generalized statement in athletics and in fitness world, that if you do a lot of vigorous endurance training, your metabolism is going to go slow. Thus, when you stop that endurance training, your body is going to accumulate a lot of fat over time. Right? Whereas here, they say that if you do endurance training, your mitochondrial content will increase. Thus, mitochondrial's capacity to generate fuel, which is ATP, will increase. So if you want to generate more fuel, you have to synthesize the raw product. So synthesizing raw product means breaking it down. So here they're saying that endurance training will help break down fat. And on the other side, they're saying endurance training will help accumulate fat.
So, sir, there is always, like, in every perspective we see in eating also, there is some quantity.
Okay.
Quantity se zyada, if we start eating, so obviously we'll gain fat. Similarly, in the exercise, if we only do the endurance training and we will not do the other strength training, so it will always harm you.
Okay.
नहीं मतलब अगर ऐसे whole perspective से वैसे देखे तो,
and that is
because only endurance training will not help you, because it will क्या कहेंगे, muscle something word याद नहीं आ रहा, muscle grow नहीं होएगी, like muscle भी hypertrophy कह सकते हैं.
muscle capacity to और strength grow नहीं होगा.
strength नहीं होगा और muscle बहुत easy word है सर, बस मेरे मुंह पे नहीं आ रहा है. मतलब हाँ, वो increase नहीं होएगी, it will decrease only.
Right. So that increase and decrease, ठीक है, that depends upon obviously what type of training you're doing and this and that. But the main point is, which you very I would not say it was unexpected, but it was not expected that you would be so 100% like bullseye on the point, right? Because this kind of question will come as soon as you become a very, very highly trained coach, and specifically a female, and specifically a fit female, you're going to have a lot of female followers. And this will be a question that comes from a very experienced female who has been and still is she's struggling, right? And you probably right now gave her the perfect answer, which is everything in excess is bad. You have to have a balance, and balance is what gets the body trained, body's growth very symmetric, not only visually but in terms of performance, right? And that is why balance is very important, and that is what ACSM or this particular course is doing. What it does is it does not tell you, you know what, you have to do strength training, it's the best. You know what, you have to do endurance training, it's the best. It will indicate all the good and bad things of each and every training, so you can put yourself where you need, and also tell you that each and everything is still needed, but you can specify it and fine tune it according to your need if you are a coach, right? So very, very impressive answer from my point of view. Amazing.
Sir, also I have one more question.
Yes.
We generally ask people, what is your goal for fitness? So your goal is to increase strength training, or your goal is for the weight loss or to maintain. So I want to ask this thing, how this I am a person and you are a coach, so you are asking me this question. But sir, मेरे अकॉर्डिंग मेरे को स्ट्रेंथ ट्रेनिंग इम्पोर्टेंट है, बट आपको नहीं लगता कि स्ट्रेंथ ट्रेनिंग इम्पोर्टेंट है? आई नीड अ बैलेंस ऑफ एवरीथिंग. सो सर, ऐसे लोगों को कैसे जज कर पाएंगे कि उसको किस चीज की ज्यादा जरूरत है?
Okay, so first things first, what you have to understand is, and what you have to also make them understand is, okay, what is your goal? So let's say your goal is to make a car, for example, right? So what do you need? First things is that, okay, no, first your goal is to make a supercar. Your goal is to make a very fast car, right? So what is the first thing you're going to need? The first thing you're going to need is the basic elements like tire, seat, this, that. Once you have all that, and once you have accumulated that into a car, then you can slowly specialize it, right? Slowly specialize it. How? Okay, now अभी आपको ये टायर्स नहीं जम रहे हैं तो okay, और अच्छे टायर डालते हैं. अभी आपको ये इंजन नहीं जम रहा है तो और अच्छा इंजन डालते हैं. अब human body cannot be assembled like that. It's already where the assembly is. So how do we judge? So what do we do, which we are going to cover later, and we are going to cover that vigorously as well, in detail as well, which is the fitness assessment and fitness test. That puts a person on a map. Okay, how far you are from where normally you should be. Not like from the athletic world, but from where you should be normally. So let's say this is the normal zone and you are here, right? So first you guide and counsel that person to get to this level. And then once that person is at that level, then we specify or we attend to his specific needs. That is, okay, I want to be into strength, or I want to be into endurance, or I want to be into flexibility. First, you get that person in all four criteria, which is strength, endurance, flexibility, and cardiovascular endurance, all four criteria, to be at that normal standards. From, let's say, because we are doing ACSM standards, so let's say from the ACSM or American College of Sports Medicine standards. Once you have that person reaching that zone, okay, chalo, now your flexibility is at a very standard level, your endurance is at a very standard level, your strength is at a very standard level, your cardiovascular endurance is at a very standard level. Now let's direct our focus towards specificity. Now you want to be a marathon athlete, we are going to keep doing strength, endurance, and flexibility, but we'll focus more on endurance. The program will be directed towards more endurance.
Okay.
Right. So most of the people that you're going to come across, they are not going to be at that level. Why? Because they might have awesome strength or awesome endurance, but maybe flexibility and cardiovascular endurance not there. So वो चारों चार criteria जब तक वो standard पर नहीं आते, तब तक you cannot enter the specificity principle. Once you have people getting there, then obviously you need super specialization. That is health and fitness specialist. You have to do that course to have a very specific क्या बोलते हैं exercise prescription.
Okay.
Right?
Okay, third point पढ़ लेते हैं. Although endurance training does not increase the phosphagen content of muscle, it does amplify the storage of energy substrates, carbohydrates and lipids used in the oxidative pathway. Glycogen, sir, इतना समझते हैं, okay. Although endurance training does not increase the So why endurance training does not increase the phosphagen content of muscle?
Because it is not being pressurized.
Okay.
अगर आप endurance training कर रहे हो तो you are gradually increasing your intensity. So your phosphocreatine cycle or your phosphocreatine energy system is deplenished, and while it is been deplenishing, oxidative and non-oxidative system are already working out, and they have enough time to start working. Right? Okay. Because it's a gradual change, so it's under no pressure. And as I had mentioned before, the quote Dr. Elizaro, right? He was an orthopedic. He said that anything and everything in the body is subjected to growth, provided the substantial pressure is added. So pressure में tissue growth होगा, या तो system growth होगा, या तो body grow होगा. अगर pressure नहीं है तो grow नहीं होगा. और endurance training में the first 2 cycle does not receive any pressure because the oxidative system has time to take over.
Okay. Glycogen, the form in which the body stores carbohydrates, is deposited in greater amount both in the muscle and in the liver of well-trained athletes. In addition, lipid depots are more pronounced in aerobically trained muscle. So lipids are
fats.
Depot are more pronounced in aerobically trained muscle. In contrast, the resistance training improves the capacity of the muscle to produce ATP anaerobically by increasing glycolytic enzymes used in the pathway along with the amount of glycogen stored in muscle. Last की 2-3 लाइन समझ नहीं आई.
So just now that we were discussing that why endurance training causes people to have more fat content in their body, right? And that is exactly what they are saying, is that in addition, lipid depots are more pronounced in aerobically trained individuals. So deposition of lipids, yani fats, right, in the cells, right, or around the cells are more in a aerobically trained individuals. Right? Why? Because when you're going on a slow paced endurance training, your body has the time to break down more saturated energy system, और ग्लूकोज तो खत्म हो जाता है 3-4 मिनट में ग्लूकोज खत्म हो जाएगा. ठीक है, तो अब उसको एनर्जी कांस्टेंट एनर्जी फैट में से लेना है, तो बॉडी ट्रेन हो जाता है कि मुझे फैट चाहिए. सो बॉडी स्टार्ट्स not only making more fat but storing more fat.
Storing more fat from where?
From the food that we eat.
Okay.
So that's why that storing of fat and that deposition of fat and then affinity towards the fat for the body, it stays even if we stop training aerobically. And if we keep training only and only aerobically, that affinity and that storage and that attraction of the body towards fat increases. And that's why aerobic training increases fat. Right? Obviously,
Okay.
now if you have 5 diesel cars, your affinity towards opening up a diesel gas station is going to be more. Right? Because you're using diesel. So you want to store the diesel. Just like, let's say for example, at home. अगर आप मैं मेरा ही एग्जांपल देता हूं कि we by mistake got a lot of oil, right? And me and my wife don't eat oil so much. And now that we are going through this Ayurvedic pitta dose treatment, right? Oil is a no-no, only ghee, right? Because oil is more hot in nature, is what they say, compared to ghee, as far as fats are concerned, right? So although we use very little fat, but that also is advised that we use only ghee. So yesterday we gave away all the oil to our friends.
Oh.
We're never going to use oil. What we're going to do? Right? So what you use more, body का उसके लिए affinity बढ़ जाता है और वो उसको store करने लगता है और उसको construct करने लगता है. Another thing is, you cannot make protein, nor can you make a carbohydrate. But you can make fat using protein and carbohydrate. Protein can be turned to fat. Carbohydrate can be turned to fat. But fat cannot be turned to carbohydrate or protein.
Right.
So that's where if a person, and this is what I've also realized, I may not be right because my database is very small, but whatever subjects that I've spoken to as far as marathon athletes are concerned or running is concerned, I've realized that all these subjects, they are trying to run or they're running to lose weight. They think that running will make them lose weight. And I keep telling them that the more you run, the more faster you're going to gain weight.
Actually,
But again, that's where you need to be an expert to deal with your body. Because at many levels, human body is not so obvious as it looks. Unless you go deeper down and then you realize it's so obvious. Now that you know that endurance training, which uses oxygen and fat as a primary source of fuel, if you train endurance, obviously you're going to use the fat. That's one point. But then because the body needs or body uses more fat, the body is going to need more fat. And thus it's going to store more fat. Right? So transparency usually comes with knowledge. And if you have half knowledge, it becomes even more dangerous. Just like in the example, right? That, running makes you burn calories. Calories come from fat. So you're burning fat. But that's just half the story. Right?
Right.
Okay. So that's what it's trying to say.
All right. Skeleton muscle.
Okay.
Skeletal muscle tissue has been specialized to move the bony.
We are done with this? Resistance training improves capacity of muscles to produce ATP anaerobically by increasing glycolytic enzymes. This is also a very important point.
Okay.
Now, resistance training, on the other hand, right, increases glycolytic enzymes used in the pathway along with the amount of glycogen stored in the muscle. Now, resistance training helps the body say that I don't need fat. I don't need to store fat because my primary action uses glucose.
Sir, resistance training to strength training hogi?
Yes. Right. So I don't need diesel. I don't need petrol. I'm using CNG. Right. So I'm going to keep CNG. So resistance training, because it uses glucose as a main source of energy, now it's going to store more glucose rather than fat. And that's where it also helps reduce fat accumulation in the body. And if we go deeper in resistance training, obviously, then we know that how fats burn.
Crazy. सर ऐसे बॉडी को कैसे पता चल जाता है कि if we are doing endurance, so we need to store more fat?
See, I believe, again, coming back to the same point, it's not body ko kaise pata chal jata hai. It's, let's say, for example, you have a child, you have a baby, right? And if you are, let's say, for example, saying that अगर आपने कुकर में खिचड़ी रखी है, right, बनाने के लिए, and the child is like, let's say, for example, he is just like 8 years old, who understands things but is not ready yet, he or she, whoever, right? So you're gonna tell him, don't touch the cooker, although you have turned off the gas. So he or she might be thinking, how does she know that when to touch the cooker? So how do you know? Either you know by your ancestors, or probably you touched it when it was not ready and it just exploded. Right? So body has evolved with experience, evolved with different environments, and to match that environment, just like how water, if you put into a glass, will take a cylindrical shape, and if you put into a bucket, if you put it into a, I don't know, a container, it will take that shape. Your body also takes the shape around the environment, right? So glucose, carbohydrates, proteins, and fats were the only primary source of energy that the planet had to offer to the biological body. So then the body developed around using it. And depending upon the molecules in that energy source, carbohydrate had only 4 molecules, protein had only 4 molecules, whereas fat had 9 molecules. Right? Right? 9. Right? So then it said, you know what? If I have 9 molecules, so I have more energy. So when do I need more energy? When I'm going to run longer. Right? So when can I use less energy? Okay, this is less energy, but less energy is easy to break down. It's very easy. It's like a wrapper. Right? It's like a Lay's wafer. Whereas the 9 calorie is like a, it's more compact, it's more packed. It's like unboxing an iPhone or any other phone. The body says, you know what? If I need energy instantly, I'm not going to sit down and unbox the phone. I'm just going to open the wrapper and use it. So this is how the body evolved around using different energy systems. All right. Now, what we have done is we have understood how our body synthesizes energy. So we have understood that how do we fuel the car and what type of fuel is used when. Now we are going to understand the motor, which is the engine of the car, which is the skeletal muscle.
Skeleton muscle. Okay. Skeleton muscle tissue has been specialized to move the bony lever of the skeleton system, thus enabling mobility or movement of the body. Okay. The skeleton muscle tissue has been specialized to move bony levers like bone ke levers of the skeleton system to enable the mobility or movements of the body.
Exactly.
All right. Other types of muscle in the body. Other types of muscle in the body includes cardiac muscle, which will be discussed later, and smooth muscle, which along other things assist in the regulation of the blood flow to various parts of the body. ठीक है. Among the three types, however, skeleton muscle is the most abundant. It accounts of nearly 50% of the human body mass. As with all types of tissue, skeleton muscle is composed of individual cells. As with all type of tissue, skeleton muscle is composed of individual cells. Skeleton muscle cells are typically termed myocytes or myofibers. The structure of the cell and the manner in which they are arranged yield insight into the mechanism of the muscle function. Okay.
It's just like a marathon you just did, huh?
So myofibers तो पढ़े थे
Hmm.
उसमें न्यू आई थिंक उसमें पढ़ा था हाँ सर ये माइक्रो एनाटॉमी ऑफ द मसल सेल में पढ़ा था मायोफाइब्रिल था वो तो एक ही बात नहीं है क्या मायोफाइबर एंड मायोफाइब्रिल
एक ही बात है
एक ही बात है
Yes.
connective tissue sir connective tissue is a type of tissue
Yes.
okay the endomysium is a epimysium endomysium is a bunch of muscle fiber ka covering
Yes.
is a layer of connective tissue that is found wrapped around each myofiber okay a group of as many as 150 myofiber lying in parallel a group of as many as 150 myofiber lying in parallel are bundled together to form a fasciculus which is encased by the layer of tissue called the perimysium ठीक है the layer of connective tissue that surrounds the entire muscle is सर ये तो पढ़ लिया
Yeah. Now hold on. Another thing that I want you to notice, which you are doing, but I think you have not realized it yet. And why I want you to realize it? Because the more you realize it, the easier it's going to be for you. And what is happening is, in terms of philosophy, what is happening here is now you have started to, what I like to say is, talk to the book. First, what you were doing is you were reading.
हाँ
Now what you're doing is as if you're communicating with the book. Why I know that? Because you read the first line and just like how I say something. So you're like skeletal muscle tissue has been specialized to move the bony levers of skeletal system. Okay. Now you ask the book again. Wait. What did you just say? And then you read again. Right? So this is what is called communication. And how can you effectively communicate with somebody? Only when you understand its language. So what this points out to me is, one, you started to understand the language. And two, now you're not reading anymore. You're communicating. Just like how we are communicating.
सर बट ये जैसे पढ़ लिया ना तो अब मेरे को समझ आ गया लाइक क्विकली कि एक बार पढ़ लिया फिर वापस पढ़ लिया तो ठीक है I now understood what is he trying to say.
Exactly.
Right? So वो थोड़ा हाँ easy हो रहा है अब.
Yeah.
Okay. So this is connective tissue. I've understood. All right. Second one is major organelles.
Major organelles.
Okay. Organelles. So मतलब?
Organs.
Major organs.
हाँ.
Major organs. Unlike most cells, an individual myofiber contains more than one nucleus. Myofiber is one myofiber contains more than
So this is one myofiber, right? This is right. This is ये पूरा एक myofiber है और myofibril, right? And it contains more than one nucleus. So this is one nucleus. Then you'll have another nucleus ऊपर. You'll have another nucleus. So one myofibril will have more than one nucleus.
Okay. Indeed, these these multinucleated cells may possess 200 to 300 nuclei of fiber length.
Per
This
of
multinuclear
fiber length. Per 2 to 300
per.
nuclei per 1 millimeter of fiber
So,
length.
sir, so one cell contains 200 to 300 nuclei per
Yes.
of fiber length. So means एक myofiber में
1 of myofibril, right, will
हाँ
have 2 to 300 nuclei.
nuclei. So sir, unlike most cells, myofiber is a cell.
हाँ.
Myo, ठीक है. Okay. The endoplasmic reticulum in muscle, termed the sarcoplasmic reticulum, is richly developed in a myofiber as the calcium is stored is needed to stimulate muscle contraction.
हाँ. So
तो सर मुझे समझ
endoplasmic
नहीं आ रहा इन लोगों ने
reticulum.
पहले ही क्यों पढ़ा दिया जब ऑलरेडी इतना डिस्क्रिप्शन में है.
Yeah, वो तो that was anatomy. To know the anatomy, you will also need to understand the structures.
हाँ.
That's where now they are using that knowledge of structure and giving you again that same knowledge as a reference point to make you understand the physiology, means how it functions.
How it functions.
Right. So let's say again, if I give you example of a car, first I told you an engine has 4 cylinders and उसमें एक crankshaft होता है और उसमें इतने injectors, fuel injector होता है, उसमें एक plug-in होता है. Now, when I explain you how the engine works, I'm gonna say there is one fuel injector that injects the fuel, and there is one spark plug that creates a spark. धमाका होता है, धमाके से piston नीचे जाता है, फिर there is a negative vacuum, वो piston फिर से ऊपर आता है, and that happens pretty 2 to 300 times per second. So it's going, that's how an engine works. Right? So for you to know how the engine works, you will need to also know the anatomical structure of the engine. Right?
Okay. So this second
so
point.
Endoplasmic reticulum is, I'll show you again. Okay. So endoplasmic reticulum, it is where proteins and lipids are synthesized. Right? So it says it usually has ribosomes attached to it and is involved in protein and lipid synthesizing. ER or endoplasmic reticulum. Right? So you have endoplasmic reticulum, which is in a cell, in a normal cell, which is a skin cell. So right here. So if you see this cell, you have, this is mitochondria right there. Right? And this is endoplasmic reticulum.
Okay.
Right? So similarly, in a muscle cell, the endoplasmic reticulum is known as sarcoplasmic reticulum, because the cell of the muscle is known as the sarcomere. Right? That's all.
Okay. So, okay. ठीक है. The plasma membrane of the myofiber is referred to as the sarcolemma. The voltage-gated sodium channels regularly distributed along the sarcolemma allow electrical stimulation of the myofiber via the generation of the action potential.
Okay, so
as a result,
keep going.
As a result, myofiber are considered excitable cells. Okay.
Yes. So myofibril can be stimulated and it can be excited. Whereas if you have a skin cell, skin may be smooth muscles hota hai. So if I electrocute your skin, the skin will move because of the smooth muscle, but the skin muscle will not move, or the skin cell will not move. Right? So what they're trying to say here is that this is the sarcolemma, right? If you can see this red thing, right? So what they're saying is the plasma membrane of the myofibril is referred to as sarcolemma, right? And the voltage gated sodium channels regularly distributed along the sarcolemma, right? So there are voltage gated channels here.
सर ये जो फिर तो कवरिंग एंडोमाइजियम इज द कवरिंग, तो सर ये कवरिंग नहीं है क्या?
नहीं, इसके ऊपर होगा कवरिंग,
इसके ऊपर, ओके,
हाँ, right?
ठीक है.
So they are saying that, okay, so voltage gated sodium channel regularly distributed along the sarcolemma allows electrical stimulation of myofibrils via generation of action potential. As a result, myofibrils are considered as excitable tissue. So what happens is, when there is signal, right? So acetylcholine, जब हमने वो देखा था ना, what is this called? This is the neuron, and it's on the myofibril.
It's a myofibril.
So this particular
motor neuron
is known as motor unit.
Motor unit.
And the junction between these two is known as
nucleo something junction.
Muscular junction. This is neuron.
Nucleomuscular junction.
Neuromuscular, not nuclear.
Neuromuscular junction.
So neuromuscular junction. Now neuromuscular junction में जैसे action potential generate होता है means electrical impulse come here, and those electrical impulse, they release the acetylcholine. Those acetylcholine will release or open sodium channels, and that will release calcium ions, right? So what that does is it happens via an electrical impulse. It's small voltage electricity. That is known as action potential.
सर जो अपन को सडनली हल्का सा करंट आता है,
नहीं, not
या फिर वो क्या होता है अभी, वो भी तो इलेक्ट्रिक
we cannot feel.
Okay.
It's very minor, very minute, and we cannot feel because that nervous system, motor neurons, are designed to absorb and designed to contain that electrical impulse. Because अगर let's say for example यहाँ से घूम के, let's say for example यहाँ से घूम के मेरे को ये टिप तक वो electrical impulse लाना है, ये movement करने के लिए, अगर मैंने यहाँ से वो electricity generate करके छोड़ दिया और बीच में वो कहीं पे लूज हो गया, तो ये मूव ही नहीं होगा ना. तो उसको इंसुलेट करना पड़ता है.
Okay.
That is insulated by something known as myelin sheath. वो later आएगा, but sometimes that insulation is degenerated, and that's where a lot of motor neuron diseases can happen, where the brain sends the signal, but the wiring, let's say समझो यहाँ से आपने स्विच चालू की, right, लेकिन लाइट चालू नहीं है क्योंकि बीच में कहीं पे वो जो वायर था वो शायद चूहे ने काट दिया.
हाँ,
हमारे केस में या तो शायद चूहे ने काटा नहीं, वो उसके ऊपर का जो इंसुलेशन, जो रबर का इंसुलेशन होता है, वो कहीं से ब्रिटल होके टूट गया और मकोड़ा या चूहा या समथिंग एल्स, इट मेड श्योर कि वो कनेक्शन मींस वो जो इलेक्ट्रिसिटी इजीली पास हो रही है वो अब नहीं हो रही, तो शायद लाइट फ्लिकर कर रही है. सेम थिंग मे हैपन इन द बॉडी एज वेल, but that will get later. That will come into pathophysiology.
Okay. So because muscle tissue demonstrate a high degree of metabolic activity, a mitochondrial content is a substantial in myofiber, providing much ATP via the oxidative pathway.
Right. So because muscle tissue is much more excitable and it uses energy, right? The mitochondrial content in the muscle is much more substantial compared to other tissues. Other tissues like skin tissue.
Yeah, joint tissue.
Joint, exactly. Right. So अगर osteophytes are the cells in the bones. So osteophyte का mitochondrial content compared to sarcomere यानी muscle का mitochondrial content will have a lot of difference.
Okay.
Right? Because it uses it. And that too continuously. Right?
Protein filaments. The contractile filaments myosin and actin account of approximately 60% of the protein content of the myofiber. Myosin is the larger protein and is sometimes called the thick filament. तो सर ये myosin protein है. All right. Actin is also a protein, right? So
that's why we need, if we need a lot of hypertrophy, right? So we need to ingest protein, because protein is synthesized into, it's broken down, and then that same protein molecules become actin and myosin. When you break the actin and myosin, right? Let's say, for example,
so like we take any kind of protein that will convert it into myosin and actin.
yeah.
Okay. So what is contractile filaments?
Contractile filaments. So actin myosin are contractile filaments. So if
Okay,
you see
they contract.
so this is thin filament is actin and thick filament is myosin.
Myosin.
Right? So they contract. They cross bridge and contract. हमने वो वीडियो में देखा था.
हाँ वीडियो देखा था.
They are known as contractile proteins.
Okay. Approximately 60% of the protein. अच्छा. So मतलब जो प्रोटीन की क्वांटिटी है उसमें 60% मायोसिन और एक्टिन वर्क करता है.
So muscle protein is 60% actin and myosin.
Myosin.
That's why if we eat meat, there is very fast hypertrophy because actin myosin is readily available.
मीट मतलब ओनली मीट या फिर मतलब चिकन विकन भी?
चिकन इज मीट.
अच्छा मीट मतलब मैं वैसे मीट लोग बोलते ना, जैसे गोट मीट हो गया, चिकन आई डोंट नो. ओके फाइन, ठीक है. मेरे को इतना नॉलेज नहीं है नॉनवेज का. मायोसिन इज द लार्ज प्रोटीन. द फिश भी मीट है.
यस. एनी एनिमल.
अच्छा किसी भी चीज, एनी एनिमल का मीट. ओके.
हाँ.
किसी भी एनिमल का. ओके.
वी आर आल्सो मीट इफ वी.
हाँ. if someone wants to eat us. Okay. Yes. Myosin is the larger protein and is sometimes called the thick filament. ठीक है. Acting is a smaller in the of a contractile protein and is termed as thin filament. In addition, regulatory filaments, troponin and tropomyosin are essential in triggering the contractile event.
वो तो हमने वीडियो में देखा था कैसे how it unlocks, how calcium unlocks. Right?
Types of muscle fiber. Although several different methods are used to classify myofibers, the most commonly one used is based on the isoform of myosin expressed by the cell. It means there are many different methods which can explain the myofiber.
Type of
but
myofiber.
The most okay.
The most common
isoform of myosin expressed by the cell. Isoform is what?
Isoform is something that I need to find an example to explain you. Let's read ahead. Let me think of an example that I can explain.
In humans, the three myosin isoform are type 1, 2A and 210. In human, there are three myosin isoform. which correspond to the fiber types of. ठीक है मेरे को ये समझ नहीं आया.
So
All right.
basically you can just say isoform or just forms which they have derived microscopically.
Okay, ठीक है. Type 1 fiber have slow twitch
So
properties.
which are the three types?
Three types is 1, 2. Oh, let's see. So this is 3 myosin isoform, which correspond to the fiber types.
Okay.
The myosin protein fiber
So
type.
forget the term isoform. Just remember that there are 3 types of myosin fibers. Myosin and sarcomeres, there are 3 types. Like you have 3 types of car. One car is SUV, one car is sedan, and one car is hatchback. Right? So SUV will be slow, but it can get you over the mountains. Sedan will be fast and can carry more load, whereas hatchback is faster but carry less load.
Less load.
Similarly, there are myofibrils which are type 1, type 2A, type 2B. There are 3 different types. Right? Now, how are they different? Because they have different properties in terms of what
So protein fiber is what? Like protein is a fiber?
No.
No, na?
Myofibril
Right.
is this. This is
the myosin is a protein.
So
3 myosin. नहीं अभी कुछ हुआ तो बात हुई थी कि मायोसिन इज अ फाइबर, कुछ ऐसे बात हुई थी. आई डोंट नो, मैंने कुछ गलत सुना होगा इसलिए मैं सोच रही थी. ऑलराइट, सो दिस मायोसिन हैज 3 टाइप्स एंड it correspond to the fiber types. So what fiber types?
So there are 3 types of fibers in terms of how fast they can contract or how fast they can react.
In general, जो fibers word है, so we have 3 types of fiber.
So this is myofibril, right? So there are 3 distinct types of it. Right? Now 3 distinct types में उन्होंने नाम कैसे दिया हुआ है? Type 1, Type 2A and Type 2B. Right? So then we have 3 distinct types. Right? Okay. So what is Type 1A?
Type 1 fiber have slow twitch properties but high oxidative capacity.
Okay, so it can use more oxygen and produce more ATP, but it is slow in reaction. Obviously, because oxygen will oxidative type of energy production is slow because it uses oxygen and fat. Right?
Type 2B myofiber are fast twitch but low oxidative potential.
So type 1 is slow twitch. Type 2 is fast twitch, but still with low oxidative capacity. High oxidative capacity. So type 1 is slow. Type 2B
is fast twitch but low oxidative potential.
High oxidative capacity.
Sir, इसमें low लिखा है.
Myofibril with low so low oxidative potential.
No oxidative potential.
Right? And type 2A are intermediate but twitch velocity and oxidative capacity. So you have 1, 2, A and B. So you have slow, medium and fast.
So sir, this type 2A is a combination of slow and fast, right?
Yes.
Okay. So here it is written both in twitch, velocity and oxidative. Velocity
Yes.
is speed, fast,
Yes.
and
Yes.
oxidative, slow. Okay.
So velocity in terms of, they're talking about how fast they can shorten.
Sure. Okay. Exercise of high intensity and short duration is principally powered by type 2 myofibers, whereas activities featuring low intensity and long duration marathon are almost exclusively depend on type 1 myofiber. Okay.
Simple to understand, right?
So mechanism of the myofiber twitch. So sir, अभी हमने पढ़ा है about the connective tissue. What are the tissues? All right. Second, we have understood that in myofiber उसमें कितने cells, कितने nuclei होते हैं. Then ठीक है कि it is rich, कैसे वो contract करता है. Then protein filaments, myosin and actin कैसे act करते हैं. The types of myofiber. So there are 3 types. Okay. So now the mechanism of the myofiber twitch. Both regulatory and contractile filaments are essential to the generation of the myofiber twitch. The regulatory filament कौन सा हो गया? Troponin and tropomyosin, right?
Exactly.
Are essential to the generation of the myofiber twitch.
Twitch means
So
contraction.
Contraction. So both regulatory and contractile, which is myosin and actin, helps in generation of the myofiber twitch.
Yes.
The force generated by the whole muscle is function of both the numbers of myofiber within that muscle that are twitching and the rate at which these twitches occur. Okay. So अगर कोई भी मसल फोर्स लगा रही है, so both the number of myofibers means
Both the number of myofibers, nahi, both the number of myofibers within the muscle that are twitching and the rate at which they twitch, right? So force generation by the whole muscle is a function. अगर एक muscle force generate कर रहा है, तो that force generation of a muscle is done by 2 things. One, एक तो कि number of myofibrils कितने contract कर रहे हैं, और second कि the rate at which they are contracting. So the number of muscle fibers and how fast they are contracting will determine the force. Why? Because watch, if I am using only one muscle fiber, तो force भी generate नहीं होगा और speed भी generate नहीं होगा. लेकिन I am using millions of muscle fibers, तो force generate होगा, और of course अगर force generate होगा तो speed generate होगी.
speed भी generate होगी.
Right? So कितना fast वो muscle contract करता है, right? And कितने muscle fibers एक साथ contract करते हैं, that will determine the force that the muscle can generate.
Okay. The sliding filament theory is myosin and
जो हमने वो वीडियो देखा था.
video में, हाँ. Theory of muscle contracting explains how these protein filaments interact to produce a twitch of the fiber. Sir, twitch of the fiber is contraction, जो बीच मतलब
Which is at microscopic level. Contraction is at the muscular level, पूरा muscle.
The sequence of event is as follows. As the nervous system excites the myofiber sarcolemma, as the nervous system
ये वीडियो के
excites,
साथ सीक्वेंस देखना है तो आपको और इजी पड़ेगा.
वो जो वीडियो,
हाँ,
हाँ चलेगा.
ओके.
You use muscles every day to do activities. This will...
Okay. Now you read the first point and वो point देखते हैं.
So both regulatory and contractile filaments are essential to the generation of the myofiber twitch.
हाँ, point A.
Point A. As the nervous system excites the myofibers
muscles to...
and it transfers tubules, calcium stored within the sarcoplasmic reticulum is released into the cell cytosol.
Okay. चलो वो देखते हैं. So what they are saying is, as the nervous system excites the myofiber, so this is the myofiber bundle and this is the myofiber muscle cell, right? So at the neuromuscular junction, as the nervous system, this electrical impulse, this is known as action potential. So as the action potential comes and excites the muscle, right, what happens is, in the transverse T tubules, calcium stored within the sarcoplasmic reticulum is released, right? So वो एक बार देख लेते हैं. Calcium stored in the ये रहा, this. So ये action potential आया और यहाँ से acetylcholine release हुआ, right? और then this action potential will create another electrical impulse which will travel via the T tubules and through the sarcoplasm. Right? And from that sarcoplasm, the calcium will come here. Right? Now, let's get back and read the second point.
Calcium binds to troponin, causing the associated tropomyosin to undergo a conformational shift, a change in shape.
Okay, so calcium binds to troponin, right?
ये release और ये release होके calcium बना, right?
Calcium नहीं बना, calcium already अंदर है. This is an electrical impulse, and these are the sodium channels, right? So because of sodium, there is a change in electrical balance, right? That change in electrical balance from positive to negative will cause the calcium ions from the sarcoplasmic reticulum, right, to enter into this electrical impulse will cause these ions to enter into the muscle fiber. And when they enter the muscle fiber, so from here they enter here, they cause the troponin to move the tropomyosin, right? So what they are saying is the calcium binds with troponin, causing the associated tropomyosin to undergo a conformational shift, right? That will open the gate so that the active filament can bind. Then what is the next point? It says because of
this shift, active sites on the acting filaments are exposed.
Yes. So sorry, this is acting filament. This is myosin. So active sites on the acting filaments are exposed, and the myosin, that's how it goes and binds with it.
हाँ, ठीक है. तो सर ये जो acting sites है, that is what?
These
yellow.
are acting sites. Yes, the yellow dots, which without calcium are covered. Without calcium, they are covered by tropomyosin.
Cross bridge heads locate located on the myosin molecules bind to expose active sites of the actin. The enzyme adenosine triphosphate, which is found on the cross-bridge head, cleaves ATP, result in the power stroke that pull acting towards the center of the myosin molecule. This sliding action of the actin over myosin result in the fiber shortening and the force generation.
So here you can see that when the sites, the actin sites are exposed, right, with the help of the calcium, right, what happens is the synthesis of the enzyme adenosine triphosphatase, which is found in the cross bridge head, cleaves ATP, right? So it breaks down ATP into ADP. ATP से ADP हो जाता है, दो मॉलिक्यूल, तीन से डाइफॉस्फेट हो जाता है, right, resulting in a power stroke. So this is known as the power stroke.
Which is known as the power stroke?
This movement is known as a power stroke.
Okay.
Right, here ATP is converted to ADP under the influence of the enzyme adenosine triphosphatase.
Phosphate.
That enzyme breaks this down.
Okay. Last point. When a new molecule of the ATP binds to the myosin cross-bridge head, the new molecule of ATP binds to the myosin cross-bridge head, the link between myosin and actin is broken, allowing the entire process to repeat itself so long as cytosolic calcium level remain elevated.
Right, so अगर कैल्शियम इधर रहेगा अंदर, जितना ज्यादा रहेगा उतना ये क्रॉस बाइंडिंग साइट ओपन रहेगा, जितना बाइंडिंग साइट ओपन रहेगा क्रॉस ब्रिज पॉसिबल होगा, provided that ATP is already there.
और सर अगर इन जनरल अगर कैल्शियम इतना नहीं पहुंच पाया और क्रॉस ब्रिज रहा एंड एक्टिंग ओपन नहीं हुए, so what will happen?
Contraction नहीं होगा.
The calcium pump is responsible for delivering cytosolic calcium back into the sarcoplasmic reticulum, thus returning the myofiber to the state of relaxation. मतलब
Means let's say for example अब कोई एक्शन पोटेंशियल आ नहीं रहा है, यानी ऊपर से कोई इलेक्ट्रिकल इंपल्स आ नहीं रहा है ब्रेन से, राइट, न्यूरोमस्कुलर जंक्शन से ट्रैवल हो नहीं रहा है, राइट, तो अब बाहर का जो क्या बोलते हैं इलेक्ट्रिकल चार्ज है वो अंदर से बदल जाएगा और कैल्शियम वापस वाया द कैल्शियम पंप विल बी मूव्ड बैक टू द सार्कोप्लाज्मिक रेटिकुलम.
Okay. All right. Okay, sir. Like पढ़े फिर?
Okay. What's the time?
4:26.
Oh, time flies by.
सर पता है क्या, अभी जैसे I'm studying तो I can study for 2-3 hours continuous, but वो अलग से मेरे से पता नहीं पढ़ा ही नहीं जाता.
अभी कैसे 2-3 hours कंटिन्यू? अभी तो आपका क्लास
नहीं, ऐसे मैं बता रही हूँ कि अभी कभी पढ़ना है तो आई कैन आपके साथ आई कैन स्टडी फॉर 2-3 hours. अलग से पढ़ना होगा फिर रात को क्या होता है कि मन नहीं होता है, मतलब 8 बज जाते हैं, फिर उसके बाद आई फील कि कुछ देख लेते हैं सीरीज या कुछ और काम कर लेते हैं.
I can imagine.
तो
We'll try to cover as best as we can.
We try this chapter, sir, in this week. Hopefully, in this week, yeah.
Yeah.
Matlab, in this month also we can try.
Okay.
And
See,
ना
आपको एक चीज बहुत बहुत इम्पोर्टेंट जो आपको करनी है, विच इज ये जो रिव्यू टेस्ट है ना हर एक चैप्टर के बाद में, उसमें हर एक क्वेश्चन का आंसर आपको मुंह जुबानी होना चाहिए।
सर मैंने एक्चुअली जब आपने 2-3 दिन पढ़ाया था उसमें से जो मैंने पढ़ा था उसकी तो मैंने आंसर सही हो गए थे मेरे, जो मैं आपको आई जस्ट हैव अ लुक, एक बार वापस ये क्वेश्चन मैं कर लूंगी सॉल्व 29 आई डू दैट, और जो नहीं हो पाएगा आई आस्क यू।
श्योर।
So we are left with the pulmonary system, cardiovascular system, ठीक है हो जाए। All right.
Right?
Thank you, sir.
Okay, chalo. I'll see you
See you tomorrow.
Take care. Bye bye.
Bye bye.